OK，非常感谢各位回来。我们今天进行今天 MySQL 这个 session 的这个 session track 的这个下午第二个 session 哈。那各位还是一样提醒各位一下，如果说您今天有问题想要提问的话，那可以看一下我们那个画面上那个 QR code， 那个 QR code 呢扫进去以后，它就进入那个 Slido。你可以在 Slido 上面提问题。那我们整个 session 的演讲完了以后呢，我们会进入 Q&A session。那个时候我们会请 Hernando 跟各位解答这个问题。OK， 那so welcome Hernando. Thank you very much for joining COSCUP and sharing your knowledge about again. And as we know that Kubernetes, kind of a focal point for in the recent year. Many people show interest in it. Of course, MySQL also want to do something against that. So recently, we just developed the MySQL operator for Kubernetes, and I think we might be able to release it soon. So it's kind of a pleasure to have you here to show our the newest product from MySQL and the Kubernetes operator for MySQL operator for Kubernetes. Hernando is the principal solution engineer of Oracle MySQL Global Business Unit, and he's based in Singapore. He's a very talented engineer and contribute quite a lot to our organization. And I think he is kind of a very important person for the Kubernetes, for the MySQL operator for Kubernetes, because it contributes a lot of code and his idea to the develop team. So it's very, it's kind of honor to have him to be here to share you something about Kubernetes. So do you want to talk anything to the audience here, Hernando?
Thank you, Ivan. Hello. Yeah, so it has been my honor as well to have this opportunity to speak to this precious event. And I hope you can enjoy the presentation, and hopefully that's useful for you.
Okay, thanks. So shall I go into the presentation? 我们可以进入 presentation 了，谢谢。
Thank you.
Hey everyone, thanks for having me. I am Hananto Wicaksono, and I'm MySQL Principal Solution Engineer. I work for Oracle MySQL. And today I would like to speak about MySQL Operator for Kubernetes. This is the latest developments with Kubernetes Operator to run MySQL InnoDB cluster on Cloud Native, especially on Kubernetes cluster. If you're looking for high availability solutions using MySQL, there are so many options to run MySQL anywhere across IT architecture landscape. On-prem deployment, you have options to run MySQL InnoDB cluster on VM or compute node for your generic or general applications. For your real-time and low latency applications, you can use NDB cluster and run it on VM or compute node. Yeah. Now we have a MySQL operator to run InnoDB clusters on Kubernetes, either Kubernetes on-prem or cloud-based Kubernetes. We also have MySQL Database Service, which is our MySQL Database as a Service offering using MySQL Enterprise Editions on OCI. You can deploy it, and it is fully managed as service by Oracle MySQL. So today we would like to talk more about deploying MySQL on the Cloud Native, especially on Kubernetes. Why we do this? Because according to survey, we believe that it is affecting a lot of customers. that 84% survey conducted by CNCF saying that organizations are using cloud native in a production. And 82% of those organizations already deploy at least 20 plus bare metal for cloud native. We believe that those organizations are using MySQL, and we want to help them by porting MySQL on a cloud native, provide them with MySQL operators for Kubernetes. So what is Kubernetes? Kubernetes is container orchestration platform to run workloads on top of the cloud native architecture. It is an open source, it is portable and extensible. And Kubernetes consists of various Kubernetes operator that enables workloads can be easily deployed, easily configured, self-healing, backup and restore, and easily to be observed. And we can create a Kubernetes custom resource for specific workloads that not exist in the standard Kubernetes. Or we can create additional operators on top of Kubernetes operator to handle our workloads. So we believe that the MySQL operator for Kubernetes and MySQL InnoDB cluster share a common goals to make it our customer easy to execute the deployment, automations, and management of MySQL-based service on the cloud native. So this is the diagram that explaining two things, how to deploy a Kubernetes cluster in the environment. We can deploy a Kubernetes worker node on top of physical server, and we can deploy also the Kubernetes worker node on top of virtualizations. And we can specify node levels and node selector to specify MySQL container where Kubernetes worker node can run this MySQL workload. There are so many popular Kubernetes environments. We have 3 on the slide, which is Kubernetes Rancher, Minikube, which is a Kubernetes standalone that can run on our machines. Or we have Oracle Container Engine for Kubernetes, or OK, run on Oracle Cloud. It is full-fledged and managed Kubernetes environment that provided by Oracle in Oracle Cloud. The good thing is, no matter how the Kubernetes platforms that user is using, those deployments are using the same YAML file and the same MySQL container images. If we talk about MySQL container, it is to run MySQL workload on top of cloud native, which is Kubernetes. But container cannot run without pods. Pod is actually a collection of one or more container run by Kubernetes and work as a unit. And Kubernetes will monitor the pods. If the pod is crashed or deleted, then Kubernetes will starting up the new pods with a new identity. Or the exact same pods will be restarted. In Kubernetes operator context, a pod can have a sidecar containers. Sidecar containers is like another container within a pod that can be used to execute the commands and can make the pod available before the main container. Even though main container is not yet running, side container can able to make the pod available. The diagram shows the MySQL container run inside the pod. Since MySQL container need to store MySQL database on the persistent storage, which is a storage volume, then we need to have persistence volume and persistence volume claim in order to mount the storage volumes to the MySQL container. so that MySQL database service or MySQL service inside the MySQL container can able to persist the data on the storage volume. MySQL container is created from the MySQL container image. MySQL 8.0 container image is available on Docker Hub, or the commercial versions, you can get it from container-registry.oracle.com. This is the Kubernetes environment while running InnoDB cluster. If we have InnoDB cluster 3 nodes, then we will have 3 pods, and each of pod will have its own MySQL container. And this MySQL container will run Kubernetes, InnoDB clusters nodes. And we will need to have MySQL routers running on container, running on another pod. Either you run it as standalone, or you can spin multiple MySQL routers in Kubernetes. And the applications that are running on another pod, the application pod, can able to reach the container that running MySQL routers through services, either cluster IP or load balancing. And the connections will be rerouted by the routers to database nodes of the InnoDB cluster. And the database service will be monitored by MEM, MySQL Enterprise Monitor. Optionally, you can also deploy MySQL Enterprise Monitor to run on Kubernetes, monitoring all the MySQL assets that are running on the same Kubernetes cluster. This diagram shows the single primary node of InnoDB cluster. InnoDB cluster has one read-write nodes, what we call it as primary. And MySQL servers within the InnoDB clusters will synchronously replicate to all secondary servers, and data will be consistent across the InnoDB clusters nodes. So secondary will have its own database that's consistent across clusters together with the primary. And MySQL router will send the write sessions from the applications to the primary server only, while read-only sessions will be distributed across secondary nodes. If the primary node down, then the next secondary will be taking over, will take over the primary role within the cluster. MySQL shell will provide admin API. It is a full administration interface to the InnoDB cluster that helps DBA to configure, to manage the InnoDB cluster easily using admin API. This diagram shows the InnoDB cluster high availability. If any node down, once the node gets available, then it will automatically rejoin to the cluster and do incremental recovery. Once the status is consistent, then that node will be running in InnoDB cluster as a secondary node. While the applications connections will be going into the routers, and the routers will know how to redirect the connections to any available or survival nodes, so that the database service will always be available from the applications labels. In case that primary node is failed, then that primary node will join back to the cluster as secondary nodes, while the clusters will promote one of the secondary nodes become the new primary. InnoDB cluster need to deploy as stateful set in Kubernetes. Reasons why: because InnoDB clusters or MySQL database is a stateful applications workload. Yeah, stateful workload. Stateful set able to manage the deployment and scaling of a set of pods and provide guarantees about the ordering and uniqueness of these pods. And the pod will have a sticky identity with a stateful set. And the pods need to be started in a specific order and cannot be replaced, because the pods need to deal with stateful set stateful workload inside. Yeah. Therefore, the good choice for deploying MySQL database or any stateful applications or workload is using stateful set. While we need to deploy InnoDB cluster in stateful set, then we have options to deploy MySQL routers as deployment or replica set, because router does not process data. It is a stateless workload. Pods that are managed by deployment are not started in a specific order. If a pod is unhealthy, the Kubernetes will create a new pod, completely a new one, but with the same functionalities. And pod state will not be persisted. As you see on the screen, this is the examples of deployment of MySQL routers manually using deployment. As we know that Kubernetes doesn't give persistent IP to the pods. Once the pod is restarted, the Kubernetes will provide a dynamic IP address to that pod, and the pod will get the new IP address. In order to provide the consistent connections from the applications to routers to InnoDB cluster, then we need to provide service. There are so many services, 4 types of service, which is cluster IP, node pods, load balancers, and external names, as you see on the screen. And once a stateful set is running, then Kubernetes will automatically create the cluster IPs. Once the replica set is running, Kubernetes also create a cluster IP as well. If we want to expose our Kubernetes resource from outside to outside, let's say to internet, let's say we deploy this Kubernetes on public cloud, then we can create a service with type load balancers so that we can expose externally the resources on the public cloud. So what is MySQL Operator then? So we know that InnoDB cluster is always, data is always consistent across the cluster's nodes that enables no data loss and recovery for an objective equal to 0. MySQL operators will create the InnoDB cluster and make it happen in a cloud-native environment. And InnoDB clusters is highly available. It is automatically failovers. Whenever the primary node or secondary node down, then Kubernetes will automatically start that pod. And once MySQL restarted within the container, then it will be auto rejoined to the clusters automatically. So it is read scalable because we are playing with a single primary mode, whereby read-write pod will only running on primary, which is a single primary, while the rest of secondary, the rest of the nodes will be running in a read-only mode as a read replica. So it is self-healing cluster. It will, the Kubernetes system will monitor the healthiness of the pods. Once the pods getting started, then Kubernetes will try to start again the pods. Then InnoDB clusters will ensure that once the MySQL is restarted within the container, it will be able to auto rejoin back to the clusters. And the operator will ensure that the InnoDB clusters service or Kube application service will automatically will be started once there is a complete shutdown of the cluster, or once there is a additional node, registering additional node to the cluster. So this is a MySQL operator for Kubernetes. Basically, it is a level 3 Kubernetes that provide full life cycles to the InnoDB cluster. It can do self-healing, it can do backup and restore, it can scale up and scale down, and it can deploy InnoDB cluster and provision the new one using clones. And this diagram provide more information about how MySQL operator deploys InnoDB clusters on Kubernetes. We have, let's say, 3-node InnoDB cluster. Then each node will have its own pod, and each pod will have two containers, which is the MySQL container where database is running and operator agent as a sidecar. And this operator agent will make sure that group replications will always running in MySQL container. And the MySQL container will have PV and PVC in order to store data to the storage volume. And this pod are deployed as stateful set. While MySQL routers is deployed using replica set, we can use a single pod to run MySQL routers as standalone, or we can run multiple MySQL routers. Yeah, stateless workload MySQL routers using replica sets. Yeah, we can run as many as possible. So this is MySQL Operator for Kubernetes. It has, feature to basically do MySQL backup using MySQL shell to OCI object storage, and so on, many more. So this is the installations, the basic installations of the MySQL Operators for Kubernetes. Basically, just deploy the CRDS using that command, and deploy the operator, okay, from GitHub. And after that, we will see that MySQL Operator is running on the MySQL Operator namespace. Once done, then we can create the password, secret. This secret basically will provide the password for root once we deploy or once we provision the InnoDB clusters, okay, in MySQL container. We need to provide root passwords, and we can set that using this secret basically. And as you see on the screen on the right hand side, okay, we have InnoDB cluster manifest, okay, using operators. So it will deploy 3 pods for InnoDB cluster and 2 pods for MySQL routers. And we can deploy this manifest using kubectl apply -f MySQL cluster.yaml file. Then it will deploy 3 pods as stateful set and 2 pods as a replica set. So once done, then we can see the deployments, online using --watch, and we can get a couple of information, okay, about the service, about PV and PVC that are automatically created. We can also, once done, we can also provide external connectivities to each of the MySQL instance by using port forwarding or load balancing. So the InnoDB cluster Kubernetes can be easily scaled out by kubectl edit IC and then followed by InnoDB cluster name. And we can set the instance variables, let's say from 3 to 5 or 3 to 7, whatever it is. Then the InnoDB cluster will be scaled up. Please remember, this is read-only scalable. Read-write will always be only a single pod because it is only a single primary mode. So, and this YAML file, the new manifest, will also deploy additional routers. From 2 routers, additional routers will be provisioned. It is automatic scaling and no downtime. The application will just keep up and running. There's no disruption at all for this. So, Kubernetes operators, MySQL operators also provide the way to upgrade MySQL instance inside the InnoDB cluster itself. We just need to use the same manifest, or we can just use kubectl edit InnoDB clusters and then followed by InnoDB clusters name to change the versions. Of course, we need to download the new image, and then this container image need to registers into the registries. And we just need to change the versions from 8.0 to 25 to 8.0 to 26 in order to upgrade from 25 to 26. And please note that stateful set will upgrade the InnoDB clusters. Start from the last port until the the first port. So we need to make sure that our primary node is running on the first port in order for having a smooth upgrade. This is a rolling upgrade, so there is no applications downtime at all. About deleting the resource, if you want to delete the InnoDB clusters in your Kubernetes, if you are using MySQL Operator, you just need to run kubectl delete IC and then followed by InnoDB clusters name. It will delete the InnoDB clusters node, stateful set, and it will delete also the replica set and all the associated service in the InnoDB cluster. So, yep. So this is the basics of the use of the MySQL operator for InnoDB clusters running on Kubernetes. Now I would like to show to you some demo. This is my demo environment. I have Kubernetes, 3 Kubernetes worker nodes running on OK in OCI. And this is my namespace. I already have MySQL operator namespace and MySQL operator pods, means that I already installed MySQL operators. And now I create a new namespace called MySQL_cluster, this cluster, that I'm going to use this to deploy InnoDB clusters. So now I'm deploying the secrets to set the root passwords when I deploy InnoDB cluster platforms. Yep. So now I'm going to deploy the OCI secret for me to be able to store my backup later on in OCI object storage bucket. Done. So I apply my secret, OCI secret. So yeah. Now I'm going to deploy InnoDB clusters with 3 pods, InnoDB cluster, MySQL instance, and 1 pod of the MySQL routers, as you see on the screens. Once I deployed, there will be 4 pods created. Yeah, 3 pods for InnoDB clusters and 1 pod for MySQL routers. So these 3 pods is deployed as a stateful set, and 1 pod of routers is deployed using a replica set. Yep, we can get the status. Now we can also log into the MySQL servers once it is up and running, and also we can use kubectl basically to log in. I mean, to show the cluster status. We can also, edit the configurations, okay, of the My clusters to increase the numbers of InnoDB clusters nodes from 3 to 5, and it is completely online anyway, and it can be done anytime. If you want to scale up the InnoDB clusters, just need to edit the configurations, yeah, using kubectl, my cluster edit, and so on. Yeah, once it is running, okay, you can have 5 nodes of InnoDB clusters. Yeah. So as you see over there, the service also created for both routers and the InnoDB cluster. So now I'm going to show to you how to back up to the OCI object storage bucket. Yeah. Yeah. So once I run, then the MySQL operator will do a MySQL shell dump instance, and then it will store the dump files to the object storage bucket, as you see on the screen. So yes, that's all. And thank you so much for your time listening my presentations. This MySQL operators for Kubernetes currently is on beta versions, and we invite everyone, okay, to test, to the POC or whatever it is, and your feedback will be highly appreciated. Thank you so much. Stay happy and stay safe and stay healthy. Thank you.
Okay. Yeah, this is a great show from Hernando. Yeah.
Thank you.
Any question? Let me check if there are any question list on the Slido. Not yet. If you want, you can type in Chinese. I can translate your question for Hernando. Yeah. In between, maybe I can have my own question for Hernando. As you showed that we can use MySQL operator for Kubernetes to deploy InnoDB cluster, scale out, and upgrade. And even we can do backup recovery. Are there any kind of new feature coming into these products, or were there any kind of a roadmap for that?
Yeah, basically, currently our MySQL operator is on beta versions. Okay, it is available for MySQL community editions only, and we are going to, we have planned to support the MySQL Enterprise editions with all the MySQL Enterprise edition features in the once we come up with the GA versions later on. So yeah, all MySQL Enterprise edition features, all those things will be available as well.
Okay. Okay, so that means that we can backup and recovery with MySQL Enterprise Backup.
Currently, we can do, these MySQL operators, even though with beta versions, okay, it works well with MySQL Enterprise editions as well. If you want to, switch from community editions to enterprise editions. Once we install first time, then it will deploy MySQL community editions. But we can always convert this stateful set to use MySQL Enterprise editions anyway. And we can use manual way to execute MySQL Enterprise backup to backup database that's running on the container. But it's outside the operators currently. But yeah, maybe in the futures, yeah. I don't have the feasibility on the plan yet. But if you want to, if you want to support the MySQL Enterprise editions, yeah, apparently that the operator will work with MySQL Enterprise backup as well.
Okay. Yeah. Thank you. Let me check. So far, we don't have a question here. Maybe you can stay for 2 minutes to see if there are any questions come out. Yeah. So it's kind of a pity because we can, the first time I send you an invitation to join COSCUP, hope that we are going to have a better situation here, but currently it's kind of disappointed that we still need to do this kind of a conference online. Yeah. Okay, I think
next year will be better situations.
Yeah, I hope so. I hope next year you will be able to, in person come to Taiwan and to meet all the audience here. Yeah.
Nice. I'm looking forward for that.
Okay. Okay, I think there's no question so far. Of course, if you have any question want to ask Hernando, you can visit MySQL Taiwan Facebook, and you can post your question there, and I will invite Hernando to join the community. And also, I can also relate the question for you to Hernando. Yeah. And thank you very much for Hernando. And this is a great share. Hope we can see you in person next year.
Thank you for the invitation, Ivan. Nice to see you here.
Yeah.
Thank you, everyone. Thanks for listening. Thanks.
Yay. Bye-bye.
Bye-bye.